may I ask you guys to come maybe like closer, like just like friendlier? Yeah. And just as a vibe check, like how do you describe your familiarity with cryptography and privacy in crypto from 1 to 5? Show me some fingers. Like, yeah, like cryptography, encryptions. So I know like the five is like very technical. One is like just okay. Sounds good. Yeah, lying. Is it better? Yeah. So I think like my key takeaway today is that like I just want to make you really confused about encryptions and privacy, because one bad thing that I've like observed in crypto is that there is like like obsession about like categorization of projects and making it like oversimplified, and sometimes it's not really helpful. It's like kind of demotivating for like new kind of projects or developers who want to contribute, and they think that it's like either already done, we are already there, or like we cannot do anything about something, right? So I'm just like randomly talking about a lot of stuff. Just the key takeaway is that there's still a very long road to build good stuff. And so like let's talk about encryption today in blockchains. Like personally, I think that like first of all there is like a typo there, but yeah, I acknowledge that. And personally, I think there's like two kind of like high level problems, which is not specifically about Web3. It's also about like Web2, and like the reason that we are not using Tor, but a lot of people are using like other kind of encryptions. And I think on the very high level, like the first problem is that this kind of privacy toolings or encryptions are inaccessible for users and developers in like major blockchains. And the second problem is that like there's a lot of misconceptions and like misunderstandings about like very fundamental cryptography schemes and why we need them and all of that. So starting with a couple of like misconceptions, I just want to like review them, because like I'm hearing that surprisingly from like most technical people in the ecosystem as well. Just which I'm also like not surprised if it's like the common beliefs in the community. Like first of all, I think the main problem is that most people think that like encryption is the same as privacy, and like privacy is only for like anonymous transfers, like hiding your balances, like shielding your transfers, like North Korea and this kind of stuff. And which is not true. First of all, like privacy is not like going to talk about later about that, is not just about anonymous transfers, and we have different kind of privacy in different layers. There's marketing reasons that a lot of projects like ZK rollups, other kind of privacy projects, they are normally saying that we are solving the privacy problem, which is not true. There is privacy in different layers. We have like IP level privacy, which is like projects like NIM. It's somehow similar to VPN, but like decentralized VPNs. It's basically you don't have privacy when you use MetaMask, so they are trying to solve that part. There is the other layer, which is like privacy of your addresses, specifically projects like Tornado Cash, like Railgun, Zcash, Penumbra, Namedot are categorized in this second layer. And there is like on-chain encryption. Is it working or? There is like on-chain encryption, which is basically your transactions, like every single move that you do like on-chain, every single message transaction is like observable by other parties, right? And the most well-known problem is probably like MEV, like bad MEV, and like front-running attacks, but it's not all about that. Even if someone is going to use that like for AI or like gaming, you are showing your hand or like products to other people. So you cannot see that, but there's like a couple of good applications that I've listed there, like leaderless auctions, like on-chain gaming, MEV mitigation, like encrypted limit orders, like encrypted share sequencing for censorship resistance, and also like confidential like AI and this kind of applications. To me, at least, is like a subset of encryption applications. And yeah, So I think it's just like my mental model of like encryption and privacy. The ordering is important because like there's encryption on that side. Encryption is not the same thing as privacy. There's like overlaps. Encryption is not, and privacy is not just for DeFi. And also it's not like there is other applications that I just mentioned, they are somehow overlapping with DeFi in some applications like auctions, but they are not necessarily the same thing. So that's like the, I don't know, easiest way that I can like communicate what's like the current situation. But like the most of the community like put all of them in the same thing. They think privacy and encryption is the same thing and it's only for DeFi, which is not true. Yeah, so another misconception is that like whenever we talk about encryption or like privacy, automatically people think it's just like ZK. It's debatable, but ZK is not like cryptographically encryption. I think there is like all of these three words, buzzwords in cryptography. We have like MPCs, TEs, like SGX, threshold cryptography, and they can be like mixed and matched. They are not going to replace each other. They are, in most cases, they are even solving different kind of problems. And the way that I see is that like they are like a toolbox sort of thing that you can mix them to solve different kind of problems. And sometimes they can solve same kind of problem in some specific situations, but there is a lot of trade-offs. And it's not going to be like ZK replacing FHE at the end of the day, or like FHE replacing threshold cryptography or signatures. It's not like the case. It's not going to be the case. Yeah. So another thing is that like this part is like probably like one of the most interesting slides, is that when we talk about MPC, in like we just had it in the previous talk, right? Most people think that MPC is just like this kind of multi-sig wallets, right? Which is like, MPC is not multi-sig, but also it's not just for signatures, right? In crypto, the most like well-known product is signatures for like multi-party wallets. But we are like those who are using MPC for wallets, it's like a threshold signature scheme. And threshold signature schemes is like on paper MPC, but it's like a very small subset of the whole like MPC categorization. And we have like on the very high level, we have like threshold signatures and we have threshold decryption. So like MPC is on top, there's two subcategories, signatures and encryption, right? And basically we can have like projects, we have like near, most of this kind of cross-chain bridges like Axelar, Wormhole, they are using some kind of MPC. For cross-chain bridges, like we have MPC wallets, it's like the most well-known use cases on the signatures part. We have encryption, so projects like us, Zama, Phoenix, Penumbra, like all of these kind of projects are not mostly in the first category. We are in the second category, right? And the other thing is that like we have projects like WorldCoin, they are talking about MPC, and like the M in MPC is multi-party, but it's very different from like how many parties we are talking about. So we have like garbled circuits is 2-party. In WorldCoin is 3-party. We have like threshold decryption, it can be like 200 parties, 200 nodes, right? So it's like somehow like very confusing for even for cryptographers that we shouldn't like generalize it. Like there is no like MPC, like M is not fixed for different kind of applications, right? Yeah, and the other thing is that, I don't know, maybe it's like somehow cool, but because of our values, but when you talk about blockchains and like privacy, immediately people think about like Tornado Cash, like North Korea, Russia, you are going to jail and all of that. Like first of all, I don't personally think is that encryption and privacy is like it's great, but it's not just about human rights and fighting your government and all of that. It's like a added value, but I think there is like some kind of monetary value for encryption and privacy. for the same reasons that like your government and like companies are having confidentiality. It's just like when you are playing poker in your real life, you don't have to show your hands. Like, so it's not privacy in that sense. It's privacy, but we don't call it privacy. It's like the business logic, the product logic that it's not like unlocked in crypto. And the other thing is that those kind of challenges, it's specifically for DeFi and specifically for mixing services like Tornado Cash and specifically for Tornado Cash. So even for mixing services, there is like some kind of projects like privacy pools by Vitalik and Amin, like who was like just here. And yeah, so there is still some kind of KYC and compliance rules that can be applied to even mixer services. But like, I just want to like highlight that it's like very specific application, very specific implementation, and like technology. So like that's kind of hurtful because I see a lot of great cryptographers that are not contributing to GitHub, to the projects out of the fear, out of the immediate panic of this kind of new technologies that can be used by bad guys. And this is like somehow like demotivating for me personally, because it's always fun to talk on Twitter at like why we're going to jail because of cryptography and all of that. And it's like basically blocking a lot of people to actually build better stuff and make more rooms for like other Ponzi schemes to show up, right? Like one other thing that I wanted to mention is like from like Protocol Labs and like the recent DOJ thing. It's not very positive, but there is like some cases that you can probably go to jail. Maybe like it's not great, but because of not having encryption, that's like the other side of the coin. So with like the GDPR thing in Europe and other regulations, if you are like a validator, you may be like, you are storing private data of the users in Europe, and that can be potentially problematic because like you are storing them, and if they are not encrypted, if they are leaked to someone, look to other countries, that can be a legal problem. Also, like the recent DOJ thing against flashbots specifically, it was like a sudden, like unfortunate, like turn of the table. They're attacking users who are using flashbot centralized servers to protect themselves from front running. So they're not attacking MEV bots, all of that. They're attacking people who are specifically using flashbots private servers. So like the answer, I think like the path forward is building like a tool that everyone is using, and you're not some specific person who is using some privacy tools. Like it should be something very general and public. So the second problem, I think, is like sorry for the shielding of our own protocol, but the second problem is inaccessibility. So coming from like Web2 background, I was like working in cryptography labs. I'm like born in Iran. We have a lot of privacy and like not having freedom for our internet and like communications. And I was like always wondering that why nobody actually used Tor, why nobody used like good VPNs. So it's like a problem that it's just like a lot of people care about privacy and freedom, but not as much as like taking the extra step of installing Tor and the slow internet, or not as much as like not like sacrificing all of the cat videos in Facebook, right? So they care about that. They choose the option if it's like available to them in the browser, in the Google Chrome, there's a lock button. They think it's like private. They just like that. A lot of people use incognito mode without knowing what's that. They think it's privacy preserving, it's cool, they use it, right? So at the end of the day, it's not like a lot of users don't like privacy. Everyone, I think, likes privacy, but it's not available. So in Web3 specifically, there is like a couple of privacy chains. I'm not saying that they're bad. It's like steps that we are taking toward like better privacy. They're isolated. So like the gameplay here is that like you should airdrop people, copy pasting like Uniswap in your own ecosystem, and then they build that. But at the end of the day, the challenge is that it's not a sustainable business. Privacy is like a very, very important feature. It's not a product, right? So like you cannot have a lot of developers and like sustainable business to like build their like applications there, and a lot of users with liquidity. At the end of the day, if you are building like DEX, you need liquidity to give better offers to people, right? So I think our vision is like bringing this kind of encryption toolings to major blockchains, like starting from Cosmos L1s and their L2s, and like hopefully like L1s like Solana and like Ethereum mainnet, right? So instead of like airdropping people and users to privacy, like we are trying to bring privacy to users, it's like a big challenge. There's a lot of technical things that should be built, but like I think that's like the way. Yeah, I think another thing is that like it's a common thing that you like people say that having encryption or privacy like fails the UX. It makes it like really hard. You need to install a Rust library. You need to like have a Giga machine for ZK proofs. All of that. It takes like minutes to generate a proof. And I think I just wanted to show that like it's specifically about ZK, and it takes like few seconds for applications. They are improving that, as they like Toggle mentioned. But it's like in other applications like FHE, like other kind of the cryptography like FHE or identity-based encryption that we are using, it takes 5 milliseconds. So just to show that, I know you don't believe me, like we've built applications on top of Cosmos, like games, like voting governance proposals. It's on our website. You can go like check our demos, play with them. They're fully functional, and you barely notice that there is like encryption, advanced like cryptography happening in the background. So that's like an educational material that we built to just show that encryption can be and ideally should be seamless like HTTPS in like Web3. And that's just like to further confuse you, there is like just 3 my favorite cryptography schemes like identity-based encryption, fully homomorphic encryption, and zero-knowledge proofs. There is a lot of trade-offs that I listed here. I'm not going over them, just to show you that there is a lot of use cases, security assumptions, like performance things. And I think the most important one to mention here is that like ZK rollups, people like they're saying that you will have privacy, but it's mostly marketing, because at the end of the day, you should send your private data to a server and they should like aggregate them. So they are not really private in that sense. And it's like a lot of people are confused about that. And the other thing is that the way that I see is that ZK is really good for proving some kind of like correctness of computation or like something about your identity, but it's at the end of the day about the data in your hand, about the computation in your hand. It lacks private input composability. It means that you cannot prove a statement about like private input of like a multi-party setup, like even in a gaming setup, even in like an auction, in a like voting thing, you cannot use ZK. And there is like folding schemes. It's also confusing. Folding schemes, you can combine 2 things like completely isolated from each other from 2 parties. It still lacks the composability of private inputs, right? So that's why a lot of people are talking about things like fully homomorphic encryption these days, because on the very high level, you can compute over ciphertext. So you can run like ML models, you can run like simple computations on top of them, which is not possible with ZK, and it can be on-chain. And as I said, like I think these are my favorite properties that we want to have, like being fully compliant. As I said, there is a lot of ways to be compliant. In some cases, you don't even have issues, like because there's like pre-execution privacy, you decrypt them, it's completely transparent. We want to make it simple for everyone, which means developers, other protocols to integrate, and most importantly, users to access that. And available in everywhere means like major, like actual chains that have users and liquidity. And programmable, which means like you can encrypt like toward different kind of conditions for decryption. The vision that I have is like a little like bold, but basically in Web 2, we have 95% of transactions, not transactions, like messages and the traffic is encrypted. Nobody knows that. My grandmother is encrypting her messages, her emails are encrypted, but she doesn't know. So that's like kind of ideology that I have, that we shouldn't really go to conferences and talk to people one by one, convince them that you should use encryption. It should be ideally convinced by, you should convince like developers, protocols to have encryption in the their applications, and their users like are just like safe and have a better user experience. Yeah, so we have the concept of composable encryption. So like we have the modularity on left side. We have all kind of projects like Axelar, Wormhole, like Celestia, or like there are some kind of side chain. They don't have their own ecosystem or applications. They are basically abstracting things that are not natively like either technically possible or very expensive. So in the case of Axelar or like Wormhole, they are like a bunch of validators that are sending their like threshold signatures or like multi-sigs to facilitate the like interoperability, like sending cross-chain messages, like cross-chain function, smart contract calls. That wasn't really possible in like Ethereum mainnet, and you can already see that the whole category is like really big and making a lot of interactions much easier. There's also the case of Celestia. They are working on DA layer as a Cosmos SDK service provider chain. There's all kind of shared sequencers as well, the same thing. And our idea is that like this kind of modularity things, basically like abstracting every like operations that are not like either expensive or not possible, like at the end of the day makes the user experience for developer, like makes it much easier for developers to build tools, and also like provides like better user experience to users. And as I said, there is like tons of cryptography schemes. It's not in most cases possible to come up with the like 42 answer to all of your problems in your life and in universe. We cannot enshrine them in Ethereum mainnet because there's a lot of trade-offs. And at least my point of view is that we should have this kind of modular like blockchains that offer you different kind of options, and they always grow, right? There's like cryptography is like growing really fast, but there's still a lot of problems to be solved. It's like one of the rare cases that the market is asking for that like much faster than the research. So I think it's important to have some kind of layer that can update itself with the market and not like changing Ethereum mainnet, for example, like that. And combining that, we have like concept of like composable encryption, which is basically means that we are abstracting away things that are not natively possible inside our own layer, like a service provider chain, and combining cryptographic security plus economic security inside that, and integrate with blockchains, like major blockchains like and like L1s and L2s, enable developers in their applications to integrate with like current applications, and like making some kind of applications that were not possible, for example, like even on the gaming and NFT side. And yeah, so yeah, I just want to to put it in a cryptography abstraction network, which is basically, I think the way that it works is that like for us, for companies like Zama or other companies, basically the path forward is that there is some kind of front-end modules, like front-end modules that can be integrated in your application, for example, like Uniswap, that basically means that when you are interacting with the application, you don't need like another front-end or like another wallet. When you're sending your transaction, it got automatically like encrypted. You can test it in our own demos as well. And once it's out, the ciphertext will be included in the, like in most cases, the blockchain itself. So they don't need to send it to our chain. And the coprocessor thing is just like the layer that I just mentioned, the one that abstracts away the computation. It can be anything in cryptography. I don't want to go into like all of the cryptography details, but basically there is a lot of operations, including DKG, threshold decryption, ring encryption, ZK verification, which is like either like very expensive in terms of like time or bandwidth overhead. And we can do that like in this kind of coprocessors. And we can see the trend that we are doing that, like companies like Phoenix is doing that, like OSIS is doing that. Like, so it's like a new kind of architectures that are popping up. And obviously that's coprocessor needs to communicate with like the applications and the blockchains that are integrated, and we have this kind of relaying mechanisms or like cross-chain message passing protocols. Yeah, and this is like example flow. For example, like if you want to, like we have like some kind of integration with CoSwap recently. So in CoSwap, it's like a centralized server, but like we still want to keep your orders on chain. and don't trust like centralized servers. It's also better for UX. Basically, you can encrypt your intents, which is like in this case like limit orders, put them on the chain, and there is like some conditions always that is needed for decryption. In this case would be the price or like an execution, a state update on your chain. And once that condition is happened, we will receive a request in our own like layer, the coprocessor, and all of our validators will generate the decryption key. And the decryption and execution happens on like the application itself. This is like how it works as a user. The takeaway is that the users don't really experience any kind of change. It's just like seamless and everything happens on the other side. And that's like the last slide. I stole it from ZK podcast, and there is like really interesting trade-off between usability, security, and performance. And there is no like kind of cryptography scheme or like anything like in engineering that can satisfy all of these like perfectly. If you are building like a game on an L2, you don't really need like eigenlayer and all of the security of Ethereum to secure yourself and have like multiple layers of like TEs and ZK. That's like cool on paper, but that's not like the way toward that. If you want to integrate with like Uniswap or like Ethereum mainnet, you probably need much higher security. And the way that I see is that for different kind of applications, for different kind of blockchains based on the stakes in risk, you need to choose your tools perfectly and sometime like combine them. So as an example, there is like MPC projects. In theory, MPC can even solve like there's general MPC schemes that they can even solve things like Schnorr signatures and ECDSA. But historically, it's like this kind of general tools are not as perfect as like tailored tools, right? So you can have that, but like it's not going to be as perfect as them. So even with things like threshold FHE, there is still like they are not going to replace like threshold signatures for that reasons. And when we talk about MPC, a lot of people like bring up the security assumptions, the security risk of like honest majority assumption. But like my 2 cents here is that first of all, you should see that like what's the actual consequences of losing that security. Like for example, in the case of Cosmos chains, like there is, for example, 10 validators holding all of the funds, and if they like malicious, they can lose you can lose liveness and safety of your assets. But in this case of like cryptography and encryption things, if you lose security, you will just go back to the current situation. There is no liveness or safety risk. It's just risking like your privacy and like the sensitivity of your information. That's like the first point. The second point is that you can always combine these like MPC things. We don't really want to go for the craziest cryptography scheme possible. I think it's important to have this kind of engineering mindset to start with something that works for simple applications and then like make it crazy step by step. So as an example, you can have MPC inside of TEs, which is perfectly secure, but like there's a still way for optimization for that. Thank you.
Thank you.